Hi friends, welcome back to our channel Physics Tutorial. Today we are going to part 8 video of electric charges and fields. So if you have not watched till part 7, please watch it before going ahead with part 8. The same Malayalam translation also I have already uploaded with this video. So if anyone wants to watch Malayalam videos, please go to our channel. Okay, can we move to the video? In the last video, we had discussed the dipole in a uniform external field. That is, in the case of a uniform external field, how the dipole acts and the equation for torque, everything that we have discussed. Okay, now we can check that. Suppose we are placing this dipole in a non-uniform electric field. Then what will happen? So, if it was uniform electric field means there was equal forces. Okay, so the forces was equal and they were constituting a couple. But in non-uniform electric field, what will happen? The unequal forces will be acting. So there will be a torque, and also in addition to torque there will be external unbalanced forces acting on the dipole. That means the translatory as well as rotational motion also will be acting there. Okay. So here we don't have to derive any equation, you just understand that if it is a non-uniform field, there will be unbalanced forces and also translatory as well as rotatory motion will be there. Okay, so only that much we have to understand. In the last video, we have already discussed the directions of the electric field and the force acting. Now, here we can see from a diagrammatic representation how the direction is changing with the direction of electric field. Okay, so here see in the first case we have the electric field parallel to the dipole moment. Okay, so here what is happening, force on minus q is opposite to the direction of field and force on plus q is in the same direction of the field. So here we can see that in the case of dipole, the direction of the net force will be in the same direction of electric field, and direction of increasing field also is in the same direction of the field. Okay, and suppose we are taking this anti-parallel field, that means the electric field is anti-parallel to the dipole moment. Then what happens? Here we can see the direction. Here the dipole moment is in one direction and the field is in the opposite direction. Then the force on plus q is forward and the force on minus q will be in the opposite direction. Then the direction of the net force will be opposite to the direction of electric field. So only these two things also you have to just remember. Okay, now we are going to the last portion of electric dipole. Here only little concepts that only we have to understand, that is the physical significance of dipole. So we have the molecules of dielectrics can be classified into two, that is polar molecules and non-polar molecules. So these names you have to remember and some examples also, right? In the case of polar molecules, what happens is that the centers of positive and negative charges will not coincide. So there will be a distance between the positive and negative charges. So what will happen there? These two charges separated by a small distance means there will be a permanent dipole moment. So that is the peculiarity of polar molecules. So polar molecules have permanent dipole moment. Okay, so we can write some examples also, H2O, HCl, etc. So these are polar molecules. Okay, so remember that there will be permanent electric dipole moment. Okay, the next type of molecules are non-polar molecules. So that will be just opposite to that of polar molecules. So what will happen here? The centers of positive and negative charges will coincide. So if they are coinciding, what will happen? There will be no distance between them, means there is no permanent dipole moment. So that thing also you have to remember. So in the case of non-polar molecules, there will be no permanent dipole moment. Okay, examples are CO2, CH-4, etc. You have to remember the examples also. Okay, and suppose we are placing this non-polar molecule in some external field, what will happen? It will convert into polar molecules. Okay, so it is possible to make polar molecules. Now we have discussed almost all the important topics of electric dipole. Hope it is clear to you. If you have any doubts or any suggestions, please comment. And now we can conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.